Everyone? So what we were discussing in the previous class? Errors. I think we were discussing errors. Errors. Daily try to remember your aim to yourself. Your aim will keep you propagating towards success, towards hard work. If you remind yourself that why you have started, then only you can be very energetic about your goal and try to work hard. Okay, every day try to work hard to achieve your goal. Remember, we all have to become doctor next year. So we have to crack NEET 24. Okay, so what we were learning in the previous class, we were doing, I think, errors. Okay, what are errors? What are errors? Whenever we measure any physical quantity, for example, we measure length of this pen. We measure a physical quantity with help of some instruments, and we compare the physical quantity property with the scale. No comparison is perfect. That's why definitely there will be some error in measurement. We are not sure about whether we are measuring correct or not. There will be some difference of the exact value of physical quantity and measured value. This difference can be higher or lower. So this difference, the error in the physical quantity is called the difference between the measured value of physical quantity and the actual value of physical quantity. We have discussed this thing. And we can divide error into various categories. Like there are two broad categories of error: systematic error and random error. What are systematic errors? The errors whose cause is known to us, they can be called systematic error. What are random errors? The errors whose cause is not known to us, they can be called random errors. Okay, random errors are random. Sometimes they are positive, sometimes they are negative, sometimes they are giving you more value of physical quantity, sometimes they are giving you less value of physical quantity. That's why if we repeat our experiment many times, it may if you take average, the positive and negative error may cancel out each other. That's why it is advised to always take multiple reading whenever you are measuring a physical quantity, and then take average. By taking average, we can minimize the random error. And we know the cause of systematic error, so we'll try to avoid systematic error. And further, systematic error we have classified in three categories. One is instrumental error, which are arising due to instrument; environmental error, which are arising due to environmental factors; then observational error. Due to human being observation, we are sometimes we are making wrong observations, so observational error. And we have, I think, also talked about gross errors. Suppose you are making some mistake in writing, or you are using a different formula. So this kind of errors are called gross error. Suppose length of this pen we have measured, and that pen length is about 15.5 centimeter. Length of this pen, suppose it is coming out 15.5 centimeter. But while writing, I am forgetting to put this point here. So it is 155 centimeter. If I forget to put a point here, it is 155 centimeter. This kind of errors are called gross error. Or one more example I can give you. If you want range of projectile is u square sine 2 theta by g. But instead of 2 theta, you are using theta. If you are writing range of projectile is u square sine theta by g. This is wrong. You should be writing 2 theta here. This is wrong. So this kind of error in writing, you are doing some mistake. You are using different formula. You are noting incorrectly. You are writing 15.5, but unit is wrong. Suppose you are writing meter or millimeter. This kind of mistakes are called gross error. Okay, so we can divide errors in broadly two categories: systematic errors, random error. Is this point clear? We have discussed all this point in the previous class. And how to represent error? We have also discussed how to represent error. We will represent error with mean value of physical quantity. Suppose we are writing value of physical quantity A. So we will measure physical quantity A many times and then take average. We will measure the physical quantity A many times and then take average. Average value is called mean value. Then we will also find mean absolute error. Mean absolute error. How to find mean absolute error? Mean value subtracted with every reading will give you error in that reading, and average of these errors. This is average error in every measurement. This is average error in measurements. This is how we represent a physical quantity which contains some error. Which contains some error. Okay. Now, we have also discussed about percentage error, relative error. So let's say I'm writing that a physical quantity, let's say time is given as 10.0 plus or minus 0.1 second. Suppose I am writing time as 10.0 plus or minus 0.1 second. So give me the percentage error in time. Give me the percentage error in time. Find 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 percentage error in time. I'm waiting for your answers. Find percentage error in time. Very good. Sham, very good. Very good. Haritha, Amritanand, very good. So, many of you are giving me correct answer. Kavita, very good. Sumaraja, wrong answer. Pramoda, correct. Very good. Jyoti, very good. Vijay, very good. Sushma, very good. Srinivas, very good. Very good. Okay, so many of you are giving me correct answer. So let me solve this question here. I want percentage error. Percentage error is defined as error divided by value of physical quantity into 100. Error, this is the error in the length or time, whatever we are finding out, error in time. And this is value of time, error in time divided by time into 100. This is the percentage error. So try to solve this. 10.0 is 10 only. It's 10. Or you can remove these points here. Then 100 will come in denominator. This 100 and 100 will get cancelled out. So we are getting 1%. Only 1%. Only 1% of error is there. Okay. Everyone is giving me correct answer. Very good. But suppose in the next question, if time equal to, let's say 12.5 second, find percentage error in time. Percentage error in time. It is given that time is measured 12.5 second and give me percentage error in time. Now tell me what is the percentage error in time. See, I am not giving you what is the error in time. I am not giving you plus or minus what is the error in time. In this kind of situations, either if they are giving us what kind of scale they are using. In this case, time, we are measuring time. So what kind of clock they are using? Either they need to give us clock. What is the kind of clock they are using? Or we will assume that this last digit is uncertain. This last digit is uncertain. No measurement is perfect. No measurement is perfect. Remember, no measurement is perfect. So every measurement contains a last digit. That last digit is always uncertain. If nothing is mentioned, I will assume that this last digit is uncertain. So error in time, I will assume instead of other digits place 0, instead of last digit write 1. So I will assume the error in time is 0.1 second. I will assume the last digit is uncertain. So I will assume the error in time is 0.1 second. Now we can find the percentage error. Percentage error, this will be 0.1 upon 12.5 into 100. Now you can solve this. What is the percentage error? 12.5, 100. So I think this will be 8 into 0.1, 0.8. Okay. So 0.8 kind of error is coming. 0.8%. Okay. 0.8%. Is this clear? Are we getting this question? Tell me. 4 by 5 or 8%. So whenever we have been not given what is the error, so we will assume the last digit is uncertain. Last digit is uncertain. We will assume the error is in last digit. Okay, error is in last digit. Okay, let me change the question. I will change the question. I will give you same data, but I will change the question. If time is 12.5 second measured with a clock with least count of 0.5 second, find percentage error. Find percentage error. I am giving you that time is measured as 12.5 second with a clock whose least count is also given. Least count is also given. Now tell me what is the percentage error. Now tell me what is the percentage error. Zamir, bilkul correct. Zamir, it's correct. Zamir, you are correct that we will assume 0.1, not 0.5. Now in this question, I have changed the something. I am giving you what is the least count of the clock. Now try to give me the percentage error. So, because least count is known to us, we will assume the error is equal to least count of the clock. When error is assumed to least count of the clock. Okay. Whenever we measure any physical quantity with help of some instrument, for example, time is measured with help of time clock. Okay. There will always some error, and that error will be assumed to be equal to least count of instrument. Least count of instrument. Least count means the minimum value that instrument can measure. Minimum value that instrument can measure, and that minimum value is always the uncertain. That is always uncertain in your measured quantity. Now we will assume the error is equal to least count. So we'll assume the error in time equal to least count of clock, that is equal to 0.5 second. So percentage error will be 0.5 divided by 12.5 into 100. Now solve this. 12.500, this is 8 into 5, 4%. Now our error is 4%. You can check this calculation, error is now 4%. Check, this is 4%. So whenever no one is giving you, whenever some error is not given, try to see whether you have been supplied with least count of the instrument, or it is not given, then assume the last digit is uncertain. Okay, we will always assume the last digit is uncertain when nothing is given, or if the least count of instrument is given, we will assume that error is equal to least count of instrument. This error is called least count error. This error is called least count error. In measurement, least count error. Whenever we are measuring any physical quantity with instrument, we will always assume instrument is causing some error in that, and that will be least count. In this question, least count is given, so we are taking 0.1. Very good. Otherwise, if nothing is mentioned, we will assume the last digit is uncertain. Very good. Zamir, very good. Everyone, is this clear? Is this point clear? Okay, very good. So one more doubt is coming. Sir, suppose t equal to 12.55 second, then error how much? If time period of, if a least count of clock is not given, one question is coming to me that he is saying 12.55 second. We are measuring time as 12.55 second. We are measuring time as 12.55 second. If nothing is mentioned about the clock, what kind of clock we are using? So I will assume only last digit is uncertain. I will assume that this much is the error. This much is the error. Last digit is uncertain. But if we know what is least count of clock, then we will use that least count as error. Understood? So if we know least count, error will be equal to least count of instrument. If we don't know least count, then last digit will be uncertain. We'll assume the last digit is error. Okay. Now we know how to represent error. Now we will understand propagation of error. Propagation of error. Propagation of error. Suppose we are measuring a physical quantity using two other quantities which have errors. For example, you are finding, suppose, change in temperature. Change in temperature. You are recording initial temperature, you are recording final temperature. Then with help of these two data, you are recording change in temperature. And initial temperature, final temperature both contain error. Both contain error. Then what will be error in change in temperature? This kind of question now we are going to address. Okay, propagation of error. Propagation of error. So write down rule number 1. Rule number 1. Rule number 1, for addition or subtraction. For addition or subtraction. For addition and subtraction. For addition and subtraction. If your physical quantity Z is A plus B or Z is A minus B. By addition of two quantities A and B, I am calculating Z, or by taking difference of two quantities, I am calculating Z. Z is A plus B or A minus B. Both will have same rule. Both will have same rule that error in Z, that is delta Z, will be error in A plus error in B. It doesn't matter if you are adding or subtracting two physical quantity. Errors are always added. Errors are always added. Here, error, absolute error in Z is absolute error of A plus absolute error of B. Add the absolute error of A and B to get the absolute error of Z. Why we are always adding? Why we are always adding? Because error can be of positive and negative type. We can get negative error in B also. If I want to measure the maximum possible error in Z, if I want to measure the maximum possible error in Z, so it will be positive error in A and negative error in B. Then negative will cancel. That's why plus sign will come. That's why plus sign will come. Always remember, we are always trying to find maximum possible error in our resultant quantity. So maximum possible error in Z will be error in A plus error in B, whether you are adding or taking subtraction. Why in subtraction we are adding errors? Because error in B can be negative. When error in A is positive, error in B is negative. Negative error of B with this negative sign will get added here. Error can be plus or minus, na? Physical quantity have plus or minus error. So with negative error of B, we get maximum error in Z. We are always trying to find maximum possible error. This is maximum possible error. Okay. So rule number 1 is clear. Everyone, rule number 1 is clear. Let us see some example on rule number 1. Let us see some example. If at 4 a.m. temperature is let's say 16.0 plus or minus 0.5 degrees Celsius, and at 4 p.m. temperature is 36.0 plus or minus 0.5 degrees Celsius. I am giving you initial temperature, lowest temperature of the day. I am giving you highest temperature of day. Okay. Find a rise in temperature. Find rise in temperature. Find rise in temperature. Rise in temperature. So temperature initial and final is given with proper error. Rise in temperature. I am asking rise in temperature. Try this. Try this question. Initial and final temperature is given. Initial and final temperature is given. Give me the rise in temperature. Initial and final temperature is given. Very good, Sham. So, for rise in temperature, I will take difference of temperature. Final temperature minus initial temperature will be rise in temperature. 36 minus 10, 36 minus 16, it will be 12.20.0. Plus or minus, errors are added, 0.5, 0.5, 1.0. This will be rise in temperature. This will be delta T. Change in temperature, final temperature minus initial temperature, change in temperature, and errors should be added. It doesn't matter whether you are adding quantities or subtracting quantity. Errors are always added. Simple. Rule number 1. In addition or subtraction, add errors, absolute error. Rule number 2. In multiplication or division. Sometimes we are multiplying two physical quantity. For example, to calculate area of rectangle, length into breadth. Or we are dividing two physical quantity. For example, speed, distance by time. So, in both the cases, relative error in Z, this is relative error, is equal to relative error in A plus relative error in B. Or if you multiply by 100, then percentage error in Z is percentage error in A plus percentage error in B. So remember, multiplication or division, both have relative errors addition. Now relative errors are added or percentage error are added. In multiplication division, percentage error are added. For example, if error in distance is 2%, error in time is 1%, then error in distance is 2%, error in time is 1%. We need to find error in speed. Speed is distance by time. So in division, we'll add the percentage error. So percentage error in distance, which is 2%, plus percentage error in time, which is 1%, will give you 3%. This is percentage error in speed. Percentage error in speed equal to percentage error in distance plus percentage error in time. Percentage errors are added. Okay. Simple example. Example 2. If, let's say, we are finding potential drop. Current in resistance is 1.0 plus minus 0.1 ampere, and resistance is 5.0 plus minus 0.1 ohms. Find error in potential drop, voltage drop. Find error in voltage drop. Remember, V equal to IR. I can find potential drop using I into R. Try to find me error in potential difference. Find error in potential difference. Very good. Some answers are coming. Very good. We need to find error in potential difference. So error in potential difference. For error in potential difference, we'll first find out potential. This is the value of current. This is the value of resistance. I know current and resistance. I know I and R. I1 R5 multiplication 1.0 into 5.0. That will be 5.0. This contain 2 digits. This contain 2 digits. So my answer should also contain 2 significant digits. Okay. My answer should also contain 2 significant digits. We need to remember rules of significant figures. So V is 5.0 volts. Now error in V by V, that is relative error in V, should be equal to relative error in current plus relative error in resistance. Relative error in resistance. I need to find error in V. That is V in division. I will write V delta I by I. Delta I by I 0.1 by 1 plus delta R by R 0.1 by 5.0. 5.0. Now I can multiply this 5.0 here. I can multiply this 5.0 here. So delta V 5.0 if I multiply 0.1 upon 1 into 5. So it will be 0.5 plus 0. These are getting cancelled. 0.1. 0.5 plus 0.1, 0.6. I am multiplying this 0.5 here. I am multiplying this 0.5 here. 5.0 here. So 0.1 by 1, it's 0.1. 0.1 into 5, 0.5. Then if I multiply this here, 0.1 by 5 into 5, 5 by 5 cancel, only 0.1 will come. So 0.5 plus 0.1, 0.6. 0.6. Very good. Sumaraja, very good. Sham, very good. Okay, is this clear? So we need to find error in V in this question. I am asking error in V. Error in V is delta V. So delta V I am calculating using relative errors. So we have done some examples based on addition, multiplication, division, every operation which we can do. Okay. Now let us go to rule number 3. Rule number 3. Rule number 3. Rule number 3. Rule of power. Rule of power. Let's say your physical quantity Z is dependent on some other quantity A with some power N. And there may be some constant of multiplication here. There may be some constant of multiplication here. Okay. K is some constant. For example, area of circle is pi r square. So area is pi into r square. N power is 2. And this constant is like pi. For example, I am taking pi. In these situations, the relative error in Z is equal to magnitude of N time relative error in A. Power is N, then multiply that power with relative error to get relative error in Z. Or you can write percentage error in Z equal to magnitude of N time percentage error in A. Percentage error in A. Okay, let us take one example. Volume of cube is A cube. This implies that percentage error in volume will be 3 times percentage error in A side length. Volume of cube is A cube. It implies that percentage error in volume will be 3 times percentage error in A. Is this clear? Everyone, are we able to understand what is the rule of power? Whenever I have physical quantity which is dependent on power of other physical quantity, okay, we will just multiply the power with relative error. There are many examples in which power is required. One of the example is this volume of cube. Volume of sphere is 4 by 3 pi r cube. If you talk about volume of sphere, that is 4 by 3 pi r cube. In this also same kind of relation will be there. 3 times error in radius will be 3 times percentage error in radius will be percentage error in volume. Okay. So whenever you have power, use this power rule. Sometime we are having an expression in which power, multiplication, division, all is there. Combination is there. For example, let Z physical quantity is A to the power P, B to the power Q, C to the power R. Multiplication of powers of A and B is there and division by powers of C is there. Now I will apply power rule, division rule, multiplication rule together. So I will write relative error in Z by power rule. It will be P time relative error in A. I should take magnitude of power P. magnitude of power, plus magnitude of power Q, plus magnitude of power Q into relative error in B, plus magnitude of power R into relative error in C. A to the power P, so P time error, relative error in A. B to the power Q, magnitude of Q time relative error in B. C to the power R, magnitude of R time relative error in C. Is this clear? There are many physical quantities in which this kind of expression usually come. I can give you a list of the quantity, a long list of formulas. For example, let's say we are talking about kinetic energy, which is half mv square. So I can write percentage error in kinetic energy, percentage error in mass, plus v square is there. So 2 time percentage error in speed. Percentage error in speed, double of that. Percentage error in speed, double of that, because v square is there now, and percentage error in mass. Addition of this will give you percentage error in kinetic energy. Very good. Shyam is giving me one good example. Potential energy of spring. Potential energy of spring, that is given by half kx square. Potential energy of spring, that is given by half kx square. So percentage error in energy, that will be percentage error in K plus 2 time percentage error in X. Moment of inertia. Next example, moment of inertia. I. For example, we are talking about cylinder. Cylinder, it is half mr square. So percentage error in moment of inertia. Now let us write relative error. Percentage error and relative error, both are similar. So I will write relative error. That will be equal to relative error in mass plus 2 times relative error in radius. There are many, a long list of quantity. Heat generated in circuit. H is I square RT. I is current in the resistor, R is resistance, and T is time. In T time, what is the heat generated in resistance? That is given by this formula. I is current. So error in percentage error in heat will be equal to 2 times percentage error in I plus percentage error in current plus percentage error in time. There are a long list of examples. Okay, so let us do one more question. If length is 1.0 plus minus 0.1%, let us make this 10.0 plus minus 0.1 meter plus minus 10.0 plus minus 0.1 meter, and time is 50.0. Let me change this. 0.5 plus minus 0.05 plus minus 0.005 second. Length is given, time period is given. Find percentage error in G, measurement of G. Percentage error in measurement of G. Okay, so in laboratory, we are calculating value of G. For value of G, error in length and error in time is given. Okay, we all know value of G is 9.8 meter per second square. How do we know this? That G is 9.8 meter per second square. That is known because by experiments we have calculated value of G. What experiment? Experiment of simple pendulum. The time period of simple pendulum, remember, that is given by T equal to 2 pi root over L by G. So here G is coming, acceleration due to gravity is coming, acceleration is due to gravity is coming. Okay, we can measure G If we know length and time period, so I can rearrange this equation, square this, you will get t square equal to 4 pi square L by G. And if you just rearrange that, so G will be 4 pi square L by T square. If you know length of simple pendulum, if you know length of string with which you are hanging a bob, you are displacing that bob and it will perform oscillation. If you measure the time period of oscillation, if you measure the length of string, then you can measure G. This is how G can be measured in laboratory. G can be measured in laboratory. We can use this concept to measure G in laboratory. So by this formula, now can you give me what will be percentage error? See what is given in question. Length is given, time is given. I want error in G. So using this, see, I can write percentage error in G is equal to percentage error in length plus 2 time percentage error in time. Because t square is there now, so I will make double of percentage error in time. So just put the values of length and time. 0.1 by 10, 0.1 by 10, 0.1 by 10 into 100. Percentage error in length. Here percentage error in length is 1%. Percentage error is 0.1 upon 10.0 into 100. So 1%. In length, percentage error is 1%. In time, 0.005 upon 0.5 into 100. If you solve this, this is again 1%. This is again 1%. So 1%, 4 pi square is constant. 4 pi square is constant. So whenever we are writing relative error, this constant can be eliminated. We can remove the constant for writing errors. Okay. Now percentage error in G, I need to find percentage error in G. So that will be percentage error in length, which was 1% plus 2 into 1, that is going to be 3%. Answer is 3%. Everyone, is this clear? Percentage error in gravity. In laboratory, G is measured using this idea, this concept. We are hanging a mass with string. We are displacing that mass a little bit and then that is oscillating. With stopwatch, we are observing this. We are measuring time for 10 oscillation, 20 oscillation, 40 oscillation. Okay. If it is leaving from extreme position, then we are observing that when it is coming to extreme position. So we are observing time period of 20 oscillation, 40 oscillations. Okay. And after measuring time period of 40 oscillation, 20 oscillation, we measure time period. Using time period and using length of string, we can measure value of G. Okay. So this kind of questions may be solved in errors. Okay. Now let us go to a special kind of concept. Okay, we have covered 3 rules of errors. Some more rules of error may be understood if you just differentiate. Whenever you want to derive relationship of error, just differentiate. Remember, dy by dx is ratio of change in y and change in x. Dy by dx is change in y upon change in x. But these changes are very small. So small change. We can write small change. And errors are also small change. So by differentiation, we can find out error of relationship of error. By differentiation, we can find a relationship of error. For example, if suppose a physical quantity is dependent by sine theta, let's say we are finding maximum height of projectile. That is given by u square sin square theta by 2g. Okay, there is some error in measurement of theta, then there will be some error in measurement of height. If there is some error in measurement of theta, then there will be some error in measurement of height. Okay, how to find it? Differentiate it. Here theta is changed now. I am asking error in H if error in theta is given. So theta and H are not related with addition, subtraction, multiplication, division, power. They do not have any simple relationship. Here sine theta is coming, sine square theta is coming actually. So this kind of complicated relation, you will need to use differentiation. Whenever you get this kind of complicated relation, use differentiation. Differentiate this equation. Differentiate this equation. Differentiate this equation. I want error in H and error in theta is given. So just differentiate this equation. dH by d theta. Assume u square and 2g is constant. U square and 2g is constant. Sine square theta. How I will differentiate that? Using chain rule. It is 2 sine theta. If I am assuming sine theta is theta, then sine square theta is 2 sine theta into differentiation of sine theta, cos theta. Differentiation of sine theta, cos theta. So dH by d theta, by chain rule I am differentiating, 2 and 2 are getting cancelled, u square by g sine theta into cos theta. Now if we want error in H, dH, so that can be written as u square by g into sine theta into cos theta into d theta. dH, error in H. d theta, error in theta. This is relationship of error in H, error in theta. This is relationship of error in H and error in theta. Okay, we need to see that this kind of factor is coming because complicated relation was there, na? So complicated answer is coming. Understood? Is this point clear? Sir, 1.00 is a significant or not? In numbers with decimal, whenever you have number with decimal, 1.0, so all the zeros behind a non-zero number are significant. This zero will be significant because this is non-zero now. All the zeros behind a non-zero numbers are significant. Okay? Is this question clear? H is given as a function of theta. We are finding error in H with error in theta. Okay. So whenever you have complicated relation, differentiation will be helpful. Okay. So remember this concept. But usually these kind of questions are not asked in this NEET exam. But let better be prepared. Okay, for complicated expression. Now we'll talk about a very important concept of accuracy and precision. Accuracy and precision, accuracy and precision, accuracy and precision. Suppose I give you this experiment of measurement of g, small g. You want to measure small g. Some two students are measuring value of small g. They are doing experiment 10 times. Two students are measuring value of g. The correct value of g is given as 9.8. I know the correct value of g. Student 1, student A and student 2 are doing the experiment of student B are doing the experiment of measurement of g. The student A is doing the experiment 5 times and he is getting the values 9.8. Second time he is getting 10.0. Every data is in meter per second square. Third time he is getting 9.6. Fourth time he is getting 9.0. Fifth time he is getting 9.8. This is the measurements given by student 1. Let's make this data a little bit change. Let us make this 9.8. 3 times he is getting 9.8, 1 time 10.0 and 1 time 9.6. So this is the readings of student A. This is the readings of student A. Okay. Sham, we will discuss also that. Wait. That is a very typical concept. We'll discuss that. Wait. Student A is measuring value of G 5 times. This is the data of student A. If you take average, you will find this average is 9.8. Take average, you will see that average is 9.8. This average is 9.8. Okay. Now student B, the recordings of student B, his first time he is getting 9.9, second time he is getting 9.9, third time he is getting 9.9, fourth time he is getting 9.9, fifth time he is getting 9.8. Fifth time he is getting 9.8. Student A records G 5 times, student B records G 5 times. Recording of student A is given, recordings of student B is given. This student, average value of his G is 9.8. Average value of other student is not 9.8, but see, data is almost same every time. He is more precise. If one performs an experiment and get close values every time his values are close, errors are less. In these situations, error is less. In this situation, error is less. So this is called precise. This is called precise. He is more precise. His errors are less. Average value is very close to every measurement. Here, there is some spread of values. There is some changes in the values. Although average value is equal to actual value. So he is more accurate but not precise. He is inaccurate but precise. His value of average value of G is not equal to exact value. Here your average will be very close to 9.9. Here your average will be very close to 9.9. But he is more precise because every time he is getting same values. This is called precision, and if your average value is close to exact value, this is called accuracy. When your measured data have average which is close to exact, you are more accurate. Accuracy means close to exact value, and precision means every time you should get same kind of result. Precision, you are precise, you are every time getting same results. So your spreading in values is less. Every time you are getting same data. This is precise, this is accurate. Now do we know meaning of accuracy and precision? Everyone, do we know meaning of accuracy and precision? Yes, okay. Accuracy means getting your result close to exact value. Precision means if you are repeating your experiment and you are always getting same kind of result, your spread is less, you are always getting values close, that is called precise. One more meaning of precision is there. Suppose I measure length of this pen using two different scales. In one scale, my answer is 15.5 centimeter. In other scale, my answer is 16.668 centimeter. In one scale, my answer is 15.5 centimeter. In other scale, let's say my answer is 15.568 centimeter. This value is more precise. If you compare this, Zamir, very good. Nice one. These two values. In these two values, if you compare these values, second value is more precise. You are giving more data, more number of significant figures. If you just compare two values, if they are asking you which is more precise, more number of significant figure means more precise. Understood? More number of significant figure means more precision. If you just compare two numbers, okay? For accuracy, I need to know exact value. Okay, I cannot just compare this and give you what is the accuracy, which has more accuracy. Whichever will be close to exact value, that is more accurate. Okay, but giving more significant digits means more precision. Everyone, is this clear? Okay, very good. So today we have covered error propagation, error in addition, error in subtraction, multiplication, division, power, and errors in complicated situations. Like this. Let us take one more example, one more special example. Resistance in parallel. This is very special example. Resistance in parallel. For series, that is very simple. R equivalent is R1 plus R2 in series. That is very simple. But in parallel, we have 1 upon R equivalent equal to 1 by R1 plus 1 by R2. Or some people also say this is R equivalent equal to R1 R2 upon R1 plus R2. but I will prefer this formula to find error. I will prefer this formula to find error. If this kind of expression is given, I want to find errors. See, they are added, but inverse is added. Inverse is added. So this is a complicated expression. For this kind of expression, we will use differentiation. We will use differentiation. So let us differentiate this. Let us differentiate this. Differentiation of 1 upon x. Differentiation of 1 upon x is minus 1 by x square. Is minus 1 by x square. So this will give me minus 1 upon r equivalent square into dr equivalent plus 1 upon r1. Sorry, equal to 1 upon r1 is minus 1 upon r1 square into differentiation of r1 dr1 minus 1 upon r2 square into dr2. I am differentiating these three terms. 1 upon x square is minus 1 by x square. So 1 upon r equivalent is minus 1 by r equivalent square into dr equivalent. 1 upon r1 minus 1 by r1 square dr1. 1 upon r2 minus 1 by r2 square dr2. dr equivalent, dr1 and dr2. These are errors. These are errors. So now we know the relationship of error. Minus, minus, minus. You can cancel out all the minus. So I am getting delta r equivalent upon r equivalent square. Error in equivalent resistance upon equivalent resistance square. That is equal to error in r1 upon r1 square plus error in r2 upon r2 square. This kind of relationship is coming. Very special case of resistance is parallel. And same will be used in this formula. 1 upon f is equal to 1 upon v plus 1 upon u. Mirror formula or lens formula. 1 upon f is equal to 1 upon v minus 1 upon u. Here also same relationship is there. Addition of inverse. Addition of inverse. Addition of inverse. Same relationship is obtained. Okay. So in complicated situations, you can differentiate and find the relationship of error. You can differentiate and find the relationship of error. But these are very complicated. Usually NEET do not ask this kind of difficult questions. Okay. But better be prepared. Is this clear? Everyone, is this clear? Zamir. Okay. Kavita, is this clear? Okay, very good, Zamir. Kavita. Okay. Okay, so today we have covered some concepts of error. Okay. In the next class, today also we have also covered concept of accuracy and precision. In next class, we are going to start vernier caliper and screw gauge. So you can come prepared, read vernier caliper and screw gauge in whatever material you can find. Read NCERT, try to read in your gym books, okay, and come prepared. Okay, so let us meet in next class. Bye bye. Take care. Thank you all of you. Bye bye.